So the Financial Times first moved to AWS in 2013. So we started with one account that was shared by more than dozens of teams. So while this did give us a lot of benefits, but we quickly found out that there were a lot of security problems that we didn't really think about with shared account architecture. Our technical directors were really frustrated because it was really hard for us to keep track of technical incidents. But today, we have small, cleaner accounts. So this talk is going to be about how we managed to turn it around. I'm going to talk a bit about FT's journey from moving away from data centers to AWS. I'm going to talk a bit about the problems that we faced with a single account architecture. I'm going to talk about the motivations behind moving away from single accounts to multiple accounts. And finally, how did we make sure that the AWS resources were compliant to FT standards? Just a bit of myself. I'm Jermila Dhas, and I'm a senior engineer at the Financial Times. I currently work in a team who look after backend content APIs, and we work with Kubernetes, AWS, Docker, and Go microservices. As we all know, the Financial Times is one of the world's leading business news organizations. We have been around for about 130 years, and we have a record-breaking readership of about 930,000, out of which 3/4 are digital subscription. As a news organization, content and website is really critical to our business. So at the FT, we truly believe in investing a lot in technology. So we also believe in empowering the teams to make their own technological decisions. If you do want to work in a team like that, we do have a few open positions right now, and we're currently hiring. Please feel free to take a look at that and come and have a chat with me later if you're interested in any of that. So moving on to the good stuff. How did it all start? It was 2011. Back in the days, we had that. This is a picture of our data center in Park Royal. We hated that. We're not really a big fan of that because A, it was occupying a lot of space, B, costing us a lot of money in terms of support, maintenance, and operations. So in 2012, we started talking about AWS, and we were really passionate about it. And we thought we should probably try and give it a go. And why did we do that? One of the concerns that we had with our data centers is, again, it was very expensive. We were spending a lot of money in terms of its maintenance and maintenance of our data centers. And we thought, if we do switch to AWS, we could probably utilize its on-demand cloud computing platform, and we could also make use of its pay-per-use feature and services, which could probably save us a lot of money in terms of operations and maintenance. And we also did not really like the traditional way of purchasing and storing additional service and storages for unexpected growth. It wasn't working well with a lot of delivery teams because we had to rely on a different team to get the hardware set up to deploy our services. And we thought if we do move to AWS, we could probably, everybody who'd have access to AWS would have the power to create resources, and they would be able to scale up and down the resources based on business, application, and service needs. This graph basically tells you how long it took for us to roll a service into production in 2011. That's when we were heavily reliant on our data centers. And as you can see, it took us about 40 days to set up hardware, and it took us about 120 days to completely roll a service into production. Versus 2014, which is when we completely adopted AWS, just took a couple of hours. We really, really liked it. And again, we thought if we do move to AWS, we could enable our delivery teams to experiment with evolving methodologies, such as containers. All good things, right? And finally, if we do use AWS, we would get double layered protection in terms of security, the first layer being offered by AWS themselves, and the second layer customized by us, which was basically an added bonus. So in 2013, we got ourselves a single AWS account, which was shared by more than 30 teams at the FT. But just 1 year later, we ended up having more than 700 EC2 instances. It was really hard for us to track who owned what. We had more than 250 terabytes of data in S3, costing us a lot of money with no clear resource ownership. We had more than 300 users accessing our AWS account, and we had more than 300 IAM users having wider permissions, wildcards. And also, we sort of lost our production cluster, one team's production cluster, but just for a very short time, but we could have lost a lot more. So what had happened was our alerts went off, and we realized that we lost content, the team that I work in, our team's production cluster in the EU region. One of our developers were running an Ansible playbook, and the playbook was terminating EC2 instances in our production account based on a team tag. So we did not specify any of our environment tag at all, so it started targeting all the EC2 instances belonging to my team and started terminating it. But then if you think about it, if we had not specified the team tag, it could probably have deleted all the EC2 instances running in that AWS account. Then we realized that the shared account setup was no longer working for us. There were just a lot of risks involved, the first and foremost being security. We thought it would be good if we could reduce the blast radius in the event of a security breach by having fewer resources, fewer users accessing our account, and less IAM keys users running around. And also, we wanted to give least privileged access to data and resources. Cost, again, has always been a concern, will always be a concern if you use AWS. We wanted clearer resource ownership of resources for better cost attribution. So in 2014, we moved from a single account architecture to a multiple account architecture. And now we have more than 600 workloads running across more than 50 AWS accounts at the company. Our delivery teams were really, really excited because we gave them their own brand new shiny AWS account, and we gave them the rights to do whatever they want to do. They had the flexibility to create whatever they want to create. But we soon realized that costs and security were not the major concern at all. Delivery teams, they cared about getting things done quickly. So what we did was we implemented a few rules to make sure the resources that they create comply with certain restrictions. And we started with security. We started by restricting access to AWS accounts based on AD groups using SAML. The way it worked is every team who had an AWS account, they had an AD group. Let's say I'm trying to log into the AWS account that my team has access to. So what I do is I browse to the ADFS side. ADFS is Active Directory Federation Service. It is a Microsoft software that provides you with single sign-on access per system. The sign-in page would authenticate me with AD. It's going to ask me for my AD credentials. Then my browser is going to receive a SAML assertion in the form of an authentication response from ADFS. Then my browser is going to send the SAML assertion to the AWS sign-in endpoint and requesting for temporary access credentials and a sign-in link. My browser is then going to receive the sign-in link and redirect to the management console of the AWS account that I have access to. So now that we have restricted access to our AWS accounts, we wanted to restrict permissions on what users can do with the resources on the AWS accounts that they were allowed to log into. And we used roles for that. As you can see, we have two roles here, FT engineer and FT IAM admin. By default, all users who have access to log into an AWS account would be able to assume the FT engineer role. And as an FT engineer, I'd have permissions to create EC2 instance or a Lambda job, but I would not be allowed to make changes to IAM policies or changes to security groups. But if one were to make potentially risky changes to a security policy or networking change, only a few named users would be allowed to do that. And they would have to assume the FTIM admin role, and they would have to be AWS certified. In doing so, we managed to restrict the access to data and resources in our AWS account. Now that we have secured our access to our accounts and our resources, we wanted to identify the critical resources which is of security concern and costing us a lot of money. And then we realized those resources were EC2, S3, and IAM. And then we thought, back in the days when we had one account, we manually went through all the resources that we had in our account to make sure that the resources were compliant. But now that we have more than 50 accounts, it's going to be even harder for us to do it manually. And we thought if we want to police things across more than 50 accounts, it probably need to be done fairly and consistently and with less manual intervention. So we wrote a module to check for compliance, and we deployed it across all our AWS accounts. The module consists of a resource definition, which is the desired configuration of an AWS resource, the Lambda job, which checks the current configuration of an AWS resource with the desired configuration, and the results are sent to the corresponding AWS config rule. So what is AWS config? For those of you who do not know, config is a service that's offered by AWS, and it is used to evaluate the configuration of an AWS resource. What it does is, it is used to automate the evaluation of a recorded configuration of a resource against a desired configuration, and it sort of reports on it. This is how a AWS config dashboard looks like. And in AWS config, you would configure rules. And as you can see, we have 7 non-compliant resources, and we'd go and check why it's non-compliant, and we'd have to fix it. So let's take IAM as an example. IAM, called as Identity Access Management, is used for controlling users' access to AWS resources. So when we had Jermila, when we had one large account, we had more than 300 IAM users, and some of the IAM users had policies with wildcards in them. Policies with wildcards can be very destructive. The resources running our website, our membership platform, our content platform were running in our single AWS account. We lost our production clusters once, but we didn't really want to risk it again. So after moving to small accounts, we gave IAM admin privileges to a few named users for every account, and they'd have to be AWS certified. These users were allowed to create users, roles, policies, but we didn't have any problems with that initially because we reduced the blast radius within their own AWS account. But unfortunately, wildcards and policies were still a thing. So we implemented AWS config rules to define restrictions on IAM policies and users. So I'm not going to go through all of them, but if you do want to know more about the different rules that we have in place, come and have a chat with me after this talk. I'll be able to explain it. But I'm just going to go through a few of my favorite ones. So at the FT, we enforce rotation of old AWS keys. Developers accidentally commit a key to GitHub, needs rotation, and we do not know how many keys have been committed to GitHub accidentally. So we enforce rotation of AWS keys most of the times. So what we have is we have a config rule in place that is going to flag all the keys that are older than 90 days. And we have a service called Governator that comes in and deactivates a key that is older than 180 days. But we do give the team fair warning that your key is going to be deactivated soon. So this is an example of an email that gets sent to a team. It basically says your key is going to expire at a certain date, and it's going to be deactivated. If you don't want that key to be deactivated, go in and rotate your key. My next favorite is wildcards. We implemented AWS config rules to flag the policies, IAM policies with elevated permissions, especially on critical resources such as VPC, EC2, for example. By elevated, I mean S3 action star on resource star, which, if you think about it, can be quite destructive because not only are you giving your IAM user permission to do destructive things on your S3 bucket, it's also going to do a lot of destructive things on everybody else's S3 bucket, which is not probably what you want. So this brings us to our next resource, S3 bucket. A specific S3 bucket, a public S3 bucket, is possibly at a risk of exposing potentially sensitive information to the public. So we have a config rule implemented that is going to flag all the S3 buckets that are public, and it's going to report on it. The main reason being GDPR, So what happens if an S3 bucket is public? We wrote a service called Governator. What it does is it quarantines an S3 bucket. By quarantining, I mean it is going to lock the access. It's going to apply a default set of bucket policies on your public S3 bucket. And the default bucket policy basically goes, the data within your S3 bucket would not be accessible by anybody apart from the users who have permissions to log into your AWS account. And we also have Governator working on EC2. We encourage teams to tag the EC2 instances with a certain list of tags. And if they don't tag those EC2 instances, Governator comes in. It goes in and threatens to stop an instance which doesn't comply with whatever we have set in place. So again, this is what happens if an S3 bucket is public, and if Governator sees that it doesn't have any bucket policies applied on it, Governator goes in and applies a default set of bucket policies. And that bucket policy would restrict the access to that S3 bucket only to the ones who have login access to the console. This doesn't happen immediately. This happens within a 24-hour window of the misconfigured bucket. But we do send them an email like that, saying that your bucket is about to be quarantined because you have not applied a certain set of bucket policies. Your bucket is public, and you should probably apply bucket policies to restrict the access of data within your S3 bucket. And once they have fixed the permissions on an S3 bucket, we send them an email saying that everything is fine, your S3 bucket is fine, I'm not going to come in and quarantine it, you're totally fine. So these are the very few things, just very few things that we did to secure our resources. Now I'm going to talk about our second concern, which is money. When we talk about money at the FT, the first thing that normally springs to everybody's mind are EC2 instances, because they are ridiculously expensive. It did cost us a lot of money, and when we had one account, it costed us a lot of money. We had no way to find out which team owned what, and it made cost attribution really difficult. So we encouraged teams to tag their EC2 instances with their team email. And if they didn't, in came the Governator threatening to but stop the EC2 instances. But we don't do that immediately. We do give teams 2 hours before Governator stops the EC2 instances. So this is a notification email that gets sent to the team. It basically goes, in this example, it basically goes, I don't see a tag called team distribution list. So if you don't tag me with a team distribution list, if you don't tag me with the tag of team distribution list, I'm going to call Governator, and I'm going to make Governator stop me. So we basically did this because we wanted clearer resource ownership for better cost attribution. This is one way of us trying to find out who costed a lot for the company. We also realized that we could save more money by migrating from RHEL to Amazon Linux or CoreOS for containers. We implemented an AWS config rule that is going to flag all the EC2 instances that are currently running on RHEL, and we encouraged our delivery teams to move from RHEL to Amazon Linux or CoreOS. We approximated the savings to about $500 for every server that was migrated in terms of license and usage. And we also flagged instances that are running on an old generation instance type. We encouraged teams to move away from an old generation instance type to a current generation instance. This is purely to save more money and to benefit from higher performance hardware. So as an example of that, so last week we migrated 30 servers from M3 to M5, and we saved $27 per server that was migrated. It's 810 in total. It might not seem like a lot, but it all adds up every month. We also flagged EBS volumes that are no longer attached to an EC2 instance, and we encourage our delivery teams to go in and delete the EBS volumes if they no longer need it. Again, going to save us money. We also flagged elastic load balancers and application load balancers that did not have any registered instances. By deleting ELBs and ALBs, we approximated the savings to be about $240 per every load balancer per year. So again, it's a lot of money that we save. We also encouraged our delivery teams to turn off EC2 instances, but just the non-production ones, but overnight and when they're not being used and over the weekend. As we all know, EC2 is an on-demand service. You get charged for whilst the server is running. So in order to make it easier for the delivery teams, we wrote a service that would go in and turn off the EC2 instances, and we called it EC2 Power Cycle. So EC2 Power Cycle is nothing but a Lambda job that looks for EC2 instances or autoscaling groups that is tagged with a tag of EC2 Power Cycle, and the value of the EC2 Power Cycle tag is a JSON document with a start and a stop in cron tab-like expression. As you can see, the first example is, say, if I tag my EC2 instance with the first tag, it's going to go in and start the instance at 8, Monday till Friday. It's going to stop the instance at 17:55, Monday till Friday. This means that we're not running our EC2 instances overnight. We're not running our EC2 instances over the weekend. And we realized that by turning off EC2 instances when it's not being used, we saved about 70% of the cost. So again, these are just a few things that we did to save us some money. And then we thought it should be everybody's responsibility to think of cost savings and compliance of resources. We thought it would be great to create awareness about the amount of money that a delivery team is spending on AWS resources. In order to do so, we need to find a better way to try and link a system and a service to a team. So we introduced a system identifier called system code, which we use to identify a system at the Financial Times. Our definition of system is a business or technical service, an application, an infrastructure component. It can be an EC2 instance or an RDS instance or an elastic load balancer. Then the system identifier, which we call the system code, is linked to a team. And the teams were encouraged to tag their resources, AWS resources, with the correct team distribution list and the system code. So what the hell am I trying to say? This is dashing. This is written by Shopify, and this is our monitoring aggregation dashboard. And this is the system definition of dashing. As you can see, it is given a system code of dashing. And teams who would have to tag the resources on which dashing is running using the system code of dashing. And then we also specify the team who is responsible for looking after dashing. So in this case, it's going to be the infrastructure delivery team. So the cost of running dashing would be attributed to the infrastructure delivery team. Now that we have figured out who owned what, we wanted to create a pretty visualization of how much a team is spending. And everybody loves a pretty graph. This is Cloud Health. You can filter AWS expenditure based on a team or a system code. You can also generate reports on expenditure and get it delivered to your inbox first thing on a Monday morning. Weirdly, that's what we do on a Monday morning. We get how much we spent on our AWS resources on a Monday morning, and we like to look at it. But one of the downsides of Cloud Health is that it requires you to have an account, and it's going to be really hard at the FT to get everybody in the technology department an account in Cloud Health. So we created our own internal tool called Smart Cloud Use. This is a dashboard for the team that I'm working in for content. It basically tells you how much we have spent on AWS and how much we've been spending weekly and monthly. And it also tells you the status of the team's EC2 estate, and it tells you how much a team can save if you were to migrate your instances from RHEL to Amazon Linux. So this is how we created awareness about the costs by the delivery team. So as a final note, I would like to think that FT took the nudge theory approach with regards to governance. There's a really nice talk about nudge theory given by Sarah Wells. She is the Technical Director of Operations and Reliability at the Financial Times. I've linked the link to a talk there, which you probably can't see. So for those of you who do not know what nudge theory is, nudge is a concept in behavioral science and economics which proposes indirect suggestions as ways to influence the behavior and decision-making of groups or individuals. At the FT, we are huge believers in empowering our teams to make the right technological decisions because we believe in an empowered team being a happy and a productive team. So we gave our teams their own AWS accounts. We gave them the flexibility to do whatever they want to do with their own accounts, and we got out of the way. But we also introduced subtle policy changes to encourage them to make the best decision with security and cost in mind when they design their infrastructure. Thank you.
Right, so quite a few questions already.
Hi, thank you for the talk. I assume that most of this tooling is now somewhat legacy. I understand that concept could be from years of experience, so you have to build some of this tooling. But namely the power cycles, I will expect an organization like FT to provide more automation in the build of these images, and you can use auto-scaling to publish these images, and then allow you to run schedulers that will stop and start them.
Again.
Sorry again. I was saying, I understand that most of this tooling might now be legacy. It's been years since you guys started producing it for AWS. But in the case of the power cycle, I assume that most of your images that are produced in an automated way that could allow you to produce AMIs in auto-scaling groups using schedulers, which you can combine with between reserve instances or spots.
So we haven't started experimenting with, your question is, can we use EC to power cycle with reserved instances?
No, the idea is you probably don't need tools like power cycle because you can do that in auto-scaling using schedulers.
Autoscaling groups. So autoscaling groups basically scales up and down resources based on requirement. So with autoscaling groups, you sort of set the minimum and the desired value for your autoscaling group. So what we do with regards to with EC to power cycle and autoscaling groups is, again, we can set EC to power cycle for your autoscaling groups. It comes in at a specific time, scales it back down, and sets it back up the next day. So yes, we do apply EC to power cycle for autoscaling groups.
Yeah. How sort of static is the number of users that you have in the environment that you just described? How many do you sort of create, delete, and how many hours do you think it takes to create a new one, maintain it, and then deleting it afterwards?
At the FT, we sort of have a policy that you should not be creating IAM users just because you can. So again, the creation of IAM users and IAM policies have been automated. If as a developer, if I want an IAM user to be created, we submit a pull request in a repository corresponding to our AWS account, and it just gets deployed automatically. So creation takes very little time. If you want to get it created automatically, and we don't really encourage manual creation of IAM users at all.
So there's no maintenance either, really, then, of each individual account?
No. But we do make sure that when they do submit a pull request with a policy, we make sure that there are no wildcard policies in it, there are no wildcard searches in it, and we only approve it when it's compliant.
Yeah. So everything's basically automated?
Everything is automated.
Thank you so much for the talk. It was really, really interesting. Between the different accounts that each team have, I mean, obviously in dev and also production, they all work together as microservices and they're operating different Amazon accounts. So for instance, let's say you've got a content team over here and you've got an ads team over here. How do you make sure each other's systems in different accounts? And I assume VPCs can talk to each other.
We use roles. So this is enabling cross-account access of resources.
Yes.
Most of the time, if it's communication between two AWS resources, we'd end up using roles anyway. So we basically rely on roles to let resources across different accounts talk to each other. And if we can't, which we really haven't faced yet because we don't really have a lot of resources stocking between accounts yet. So we haven't really come across that specific situation yet.
Okay, thank you.
How do you handle cost attribution for microservices, Kubernetes and things like that?
Again, it's expensive. We know that Kubernetes is very expensive because we have a controller, worker, and an etcd. So what we do is, in our team, our microservices are running on a Kubernetes platform. All we do is we get our monthly report, and we try our level best to try and look at the type of instances that we're using to see if we could make anything better. But then again, we just look at our reports that we get and see if we could try and make it better by upgrading to the latest instance type is what we normally look at.
Any last question?
Thanks, Jermila. That's a fantastic talk, really inspirational. I was just wondering if you had any insight into how you got your CIO or CTO to kind of go along with this, especially in an age where everyone feels very cautious, especially, I think you mentioned GDPR and that sort of stuff.
So one of the good things that I really like about the FT is we like experimenting with new technologies all the time. They sort of just let you, we have this thing called 10% day. Once every fortnight on a Monday, they'd go, do whatever you want to do, experiment with whatever you want to experiment with, come back to us and tell us what you learned from it, and tell us why you think that is something that we need to try out. And that's how this happened. So we were a bunch of developers. We were sent out. We were asked to experiment with deploying services onto AWS. We were asked to talk about how we could benefit the company if we do move to AWS, and that's how this happened.
So I guess you're saying that you made the case based on sort of cost and delivery timelines, that sort of stuff.
Cost, but we also think about performance and quality and automation.
Okay, thank you very much.
Can I just say thank you to FT for being very open and sharing this tonight. Thank you very much.
Thank you.
Yeah. Thank you very much. It's been brilliant. Okay, guys. Well, as usual, we got drinks and